So now we're going to talk about something new. And let's read this problem together. This is a problem that will kind of give a flavor for what we're about to start talking about. And these kind of problems come up often and are very useful. Okay. So here we go. The theater sells adults tickets for $11 and child tickets for $7. If 25 tickets are sold and the movie theater's income was $219, how many tickets of each type were sold? This is a new kind of problem. This problem is unlike the other problems that we've dealt with before. And I'm going to start setting it up as a way of showing kind of the flavor of what's coming out of this, and then I'll explain what this new material is about. So the first thing I'm going to do is I'm going to label, I'm going to give my variables names. So I'm going to let A denote the number of adult tickets. Or let's just say, let A be the number of adults. By the way, I'm not writing it in complete sentences just to save time. So let A be the number of adults. Okay, that's much better. Be the number of adults. And let C be the number of children. Okay. So now if we read this problem again, we can see that the theater sells adult tickets for $11 and child tickets for $7. And it says that 25 tickets were sold in total. It says 25 tickets were sold. So somehow we must have that the number of adults plus the number of the children has to be 25. But now it also tells us that the movie theater made $219. So we must have that 11A plus 7C has to equal $219. Okay. And you might say, well, David, this kind of looks similar to problems we've had in the past. What makes this one special? Why is this one different? And the reason it's different is that both of these equations have to somehow be solved at the same time. We need to find a number of adults and children that add up to 25, but at the same time such that 11A plus 7C gives us 219. So this kind of situation where we have to solve two or more equations at the same time for two or more variables is called a system, well, and in this case they're linear equations, so we're going to call them systems of linear equations. If they were not linear equations, they would be just systems of equations in general. Here we're going to focus on linear equations just to get an idea of how we solve them and stuff. And so this then is the motivation for this part. And I'm going to use this example to demonstrate how we solve this system and how we find out how many adults and children attended. And so there we go. Systems of linear equations. Ta-da!